Okay, let's start. We did this till last class. So I'm going to question ask you. We'll look into gravitational potential, the non-uniform version. So this is the uniform relationship. So when you are in a uniform field, the variation of gravitational field strength is constant. So you can just use mgh, and that's what we saw so far. So how does it behave in a non-uniform field? Which আজকে দেখবো. So if you have any questions from here, you can let me know. Okay, let's start. So we'll start with a new quantity called gravitational potential. So let's start with that. Right. So just like before, there's a bit of an issue when we talk about GPE. I'll explain why. So if you remember that when we try to compare strength of two planets, we didn't use the force. We rather use their field strength, right? So you have a planet here, you have another planet here. We do not know what the planet's strength of gravity is, right? So I'm going to planet A thake and planet B thake. And let's say there's a mass here whose GPE above the planet, this is GPE, above the planet is, let's say, 1500 joules. Okay, so the GPA above the planet is 1500 joules. And it is 4000 joules. Now, can you tell me which planet has a stronger gravitational field? I've not defined the height. I've not defined the mass. I've only provided you the amount of energy here. This energy is called gravitational potential energy. So gravitational potential energy. So if this is the energy provided to you, my question is, which planet has a stronger gravitational field? Would you be able to say? I have not provided you with any other information, no mass provided, no height provided. So eventually you can understand it's not possible, right? It could be a very small mass in a very strong field that gives you 4000, or it could be a very large mass in a very weak field that gives you 1500, right? So you'll find it easier in future that we always want to standardize our values, okay? So standardize kemne kora hoy. So I'll give you a table here. Table should help you out, figure out how to standardize. So this is the actual value, so actual magnitude. And this is the standardized version. What's the standardized version? I mean, in a minute. Standardized value. So I won't give you numbers. I'll actually give you quantities, okay? Can you tell me what's the name of the force between any two masses out there? What do we call that force? A force of attraction between any two random masses, right? What's it called? Yeah, gravitational attraction, right? Or gravitational force. So you have to gravitational force. That's the actual value, gravitational force. Can you tell me what is the standardized version of it? Gravitational force হচ্ছে the actual force between two masses, right? What's the standardized version? So standardized version মানে কি? You don't really need to know what the object is. You don't need to know where it is, right? How it is. It's just what that amount of object experiences in that field generally. Okay, it's basically a value for comparative purposes. So কি ছিল এটা? 9 point, yeah, 9.81, right? So 9.81 is the value, but what's the name? What do you call that 9.81? No. I remember the last two class back করলাম. What was the quantity that allows you to compare the strength of two planets? Last class we discussed করছি. Online যারা বলছি, you're right. Yes, that's the correct answer. But what is it? That quantity that helps you compare the strength of two planets' gravity. Not the force, because force is the problem. So force is flawed. Force can be more or less depending on what mass you're working with. Standardized version হচ্ছে for every unit mass. Yeah, gravitational field strength. What happened? এটা তো পারার কথা, gravitational field strength. So gravitational field strength is for what? 1 kg. So এটাকে বলা হয় standardization. Standardization মানে হচ্ছে you're trying to find the value for each kilogram. So এটার ইউনিট কি হবে ফোর্সের? নিউটন। এটার ইউনিট কি হবে? নিউটন per kg. And you know, that's very easy to compare because you don't have that confusion anymore. Is it a big mass or a small mass? Because that could change your value. It is the same mass. So if you're comparing same mass, isn't it easier for you to figure out what the force is or which is stronger, right? So আমাকে যদি এখন বলে যে জুপিটারে হচ্ছে gravitational field strength is 29 আর মুনে হচ্ছে 1.6, I know easily which one is stronger, right? And how much stronger. Okay, so that's gravitational force and field strength. Can you tell me actual magnitude taken হচ্ছে, এটা তোমাদের বলে দিচ্ছি। So this is called gravitational potential energy. Gravitational potential energy. What is this? This is the amount of energy possessed by a mass when it's in a gravitational field, right? That's called gravitational potential energy. But Ujay, same problem again. It could be a big mass, small mass. It could be very high, very low. I mean, you know, there's so many other values out there. So how do we standardize this? So standardization, as you know, you have the quantity gravitational potential. So gravitational potential is nothing but how much potential energy a mass possesses per kilogram, right? And now it's very easy for me to compare the value of the energy in the field. Why? Because I'm comparing for like to like, same mass, right? আমি যদি তোমাকে random বলতাম যে পাশের example 4000 and 1500, I have not given you any further information. It is not possible for you to compare. I mean, you might end up getting an answer by guessing, but there's no concrete value here that tells me কোনটা strong, কোনটা weak. But when I compare this, right? কেমনে compare করবো আমি দেখাই তোমাদেরকে। See, if I told you the field potential here is 200 joules for every kilogram, and the potential here is 100 joules for every kilogram, isn't it now a better comparison? That I know for every kilogram, one possesses 200 joules, the other possesses 100 joules at the same height. So isn't it now a better comparison, a fair comparison? ওইটাকে বলা হয় gravitational potential. Why am I giving this thing to you? Because তোমাদের হচ্ছে syllabus মধ্যে এই থিমটা প্রায় আসবে, that you know the actual value is not really helpful. It is helpful when you want to actually find out what acceleration you're experiencing, but when you want to compare, what do you always compare? A standardized version. A standardized version could be per kilogram, per joule, right? Per kilogram, per coulomb. So electric field strength ছিল তোমাদের ওলা বলছে briefly. Electric field strength কি ছিল? The amount of force experienced by a coulomb charge in a field, okay? A unit coulomb charge bola hoy. So that's easy to compare, okay? Anyways, just try to understand that actual value ta lage when I really want to find out what's happening. But when I want to compare, I would prefer using what value? Standardized. So this is for calculation purposes. You really want to know now how much energy is in a object here. তখন standardized করে লাভ নেই তো, এটা তো 1 kg না। How much is it? 200 grams. So don't I need to know how much this actually possesses? তখন I'll find the energy. But if I want to know how the strength of gravity is in this room, I have no mass with me. আমাকে একটা mass assume করে নিতে হবে তো, right? What would be the most, common mass that somebody should assume? Common sense বলে 1 kilogram, right? It's called a unit mass. It's the best way, right? So this one is used for comparative purposes, okay? So we use this value for comparison. So when you compare something, you use standardized value. When you want to find the actual force, actual acceleration, actual energy, you use these values here. Okay, so it's a theme. It's not like something that is like part of our topic here, but you'll start to notice this everywhere. So যে ওইখান থেকে এখানে আসলাম আমি, what's gravitational potential? So gravitational potential হচ্ছে, আর এটা একটু complicated. স্ক্রিনে দেখো, if there's one topic that I think is a little challenging এখানে in A2 তে, this is one of those. Okay, so you have a mass here and there's a mass placed in the field here, and you want to find its gravitational potential energy. Now typically the right way would be to take it from where? The center of the mass, right? So that is it. So এখান থেকে যদি center of mass থেকে now, the maximum that the object can reach is the what of this mass? Surface, right? And that is fine. And then we talked about this last class that, whenever you have an object fall in, it will continue to fall, right? Potentially until it reaches the what of that planet, center of the planet, right? But the problem is, are all planets the same size? No, right? And then is the radius of everything that we're dealing with the same? No, right? Somebody is zero consider Kori as the center. Let's say this is 0 joules. The problem is, to get to zero, for some planets, you might have to travel 6,400 kilometers, like the Earth. But for some planets, that zero is only 2,000 kilometers inwards. So isn't that a variable, right? And that's a bit of a confusion, because eventually zero to reach korba is different for every planet, right? Or any object. So they decided to do something here. Zero to they decided that they won't take the center of the Earth zero. And they decided that the mass can only reach till what of a object? Surface. So surface is the closest possible location, okay? Closest possible location to the mass. তাহলে জিরোটা কোথায়? So here comes something interesting. As we start to go further away, right, the value of G, is it increasing or decreasing? The value of G decreasing, right? And what's the formula? G equals to Gm divided by, Gm divided by d square or r square, where d is that distance there. That's the value, right? What's the relationship between G and d? Center থেকে, you're right, sorry. Center of the mass. So what is the relationship between G and D? Inverse square law. Inverse square law means the further you go, the value of G decreases by what factor? Square factor, right? So এরকম করতে করতে, if I go to a distance that is infinitely far away, okay? So this close to infinite. So let's say you are at infinity, right? What do you think the value of G would be? Close to zero, right? তোমার যদি distance যত দূরে যাবে, এটা যত হচ্ছে বাড়বে, আমি arrowটা change করে দিই, এটা যত বাড়বে, because you're going infinitely far away, right? What does the value of G become? Zero. And this is a problem. You know why it's a problem? Any system out there has how many places where GP is zero? 2 places. At the center of the mass and আরেকটা কোথায়? At infinity. তোমরা কি বুঝছো what I'm trying to say? I will repeat করি. If I take a random mass out there, how many places do you have a GP of zero? GP of zero is zero at the center of the Earth, because that's the place where truly H এর value কত? Zero. So if H is zero, you're not at any height. How much energy do you possess? Zero. But when you go infinitely far away, তখন আরেকটা quantity zero হয়ে গেছে। কোনটা? G. When you think of the formula mgh, right? In the formula mgh, mass to constant, there are two things that are changing, G and height. So height যদি zero হয়, where are you? Center of the Earth. তাহলে আমার GP কি zero আসবে? আবার G যদি zero হয়, where are you? Infinitely far away. তখনও zero হয়. So that's the problem. কেন problem? If I take a random mass out there, the value of GP is zero at 2 places. At the center, এখানেও 0 joules. আর আরেকটা হচ্ছে this imaginary location which is very far away, infinite. And এই infinite যদি reach করো, the value of GP is going to be how much as well? Zero. কেন? So at infinite, who's responsible for the GP becoming zero? Field strength, right? So এখানে হচ্ছে G is zero, hence GP is zero. Our center A, why is it zero? Yes, H equals to zero, hence GP is equal to 0. Do you understand? So there are two zeros out there. Now you can't do a map with two zeros in it. I mean, two locations mean zero. The math doesn't work. So eventually, what they decided was to consider infinite as zero. So এখন থেকে যেটা আমরা করব, we'll consider when a mass is infinitely far away, what is the GP it possesses? Zero. Okay. Why is this a better choice than the other way around? I'll explain in a minute. If you did the other way around, you had to go to where for your GP to be zero? The center, the literal center of the mass. Is it in real life physically attainable? No, right? When you're going to a planet, you're going to a star, you're going to a moon, you only stop at what point of that flat surface, right? So it is attainable না এইভাবে কাজ করলে it is possible, but it is not very user friendly. So they decided to do the reverse and they consider infinite to be what? Zero. If you go beyond infinite here, মানে কোনোভাবে, তাহলে the value would be positive. And if you go beneath infinite here, the value would be what? Negative. And as a consequence, all GP values are what? Negative. আচ্ছা, so এখন থেকে আমরা যখন ম্যাথ করবো দেখবো সব GP values negative আসতেছে. And the reason why it's negative is because we have considered infinite to be what? Zero. And everything is beneath infinity for us. মানে আমরা কি infinity বাইরে না নিচে? Niche, right? So all the values will be negative out there. And that's something where you can't ignore. Because, I told you to ignore the negative sign in the previous topic, minus GMM by D square, because that was symbolic. There was no actual, mathematical implication on it, right? But here, this is actually mandatory, okay? Negative tab. And now you'll find something that I told earlier will make more sense. Remember, I said that when a mass falls, right, it loses GP. When I said it, so what did I say was the sign when it went down? Negative. So that's why it makes more sense here. Doesn't or negative than you said. Okay, so it's losing GP, so naturally it's a negative sign. And you have considered infinite to be zero, so all the numbers beneath that would be also what? Negative, right? So that is what we do. This is called gravitational potential. Now, what's the definition of gravitational potential? There are two versions out there. আমি হচ্ছে দুইটাই লিখে দিচ্ছি তোমাদেরকে. One you have to write in the exam. One is something that I use for explanation purpose. Okay. Just give me a couple of minutes. আমি সবকিছু লেখার পরে তোমরা copy করো. So gravitational potential has a new symbol. It is phi. Do you know how does phi look like? Yeah, that's right. So that's phi. Okay, phi equals to minus gm divided by d. This is the equation for gravitational potential. Now, what is gravitational potential? Definition day. So this is gravitational potential. তোমাদের অনলাইনে যারা কোয়েশ্চেন করতেছে আমি অ্যান্সার করতেছি in a minute. This is called gravitational potential. And এটার হচ্ছে there are two versions to this definition. আমি হচ্ছে first এই ভার্সনটা দিই তোমাদেরকে. এটা unfortunately exam এ allowed না. এটা বুঝতে পারি easier. Okay, so gravitational potential হচ্ছে it is the amount of energy. Yeah. This is not allowed in the exam, by the way, okay? আমি বুঝাচ্ছি ওরা কোনটা চায়. That's a different version. It is the amount of energy possessed by a 1 kg mass in a gravitational field. Right, so this is the version. এটা মনে রাখতে easier so that you know what the unit should be. So can you tell me what the unit should be here, gravitational potential? It is the amount of energy possessed by 1 kg mass in a gravitational field, right? What should the unit be? Yeah, joule per kilogram, right? Right. So question হচ্ছে, what's the official definition, Thales? The official definition is this one, and I'll explain what it does. Right, so this is your official definition for gravitational field strength. Sorry, gravitational potential, eta. So exam it comes for 2 marks. হ্যাঁ নিচেরটা সো এক্সামের নিচেরটা লিখবা উপরটা কেন দিলাম তাহলে উপরটা বুঝতে ইজিয়ার তুমি এখন নিচেরটা যদি দেখো ইউ উইল ফাইন্ড দ্যাট it's not that straightforward but upperta is easy to understand so for understanding purpose we'll use the first definition but when it comes to exam and you have to write the definition I would recommend write the second one okay so I'll explain all of these okay don't worry I'm just gather inshallah. Yeah, the negative is not symbolic here. So negative কেন এখানে এটা 3-mark question একটা why is it negative? I'll give the answer in a bit, but এটা mainly because হচ্ছে all values are below the 0 since infinite is considered to be 0. That's one of the reason, and the other reason it that when objects are falling, right, are they gaining GP or losing GP? Losing. And how do you signify a loss? Minus. Okay, so that's the other reason. Right, so a definition to the gravitational potential is the amount of work done, amount of work needed to move a unit mass from infinity to a point in the gravitational field. Let me explain what it means. So আমার যদি phi value আসে, let's say -47500 joule per kilogram, what does it mean? A definition পড়ে আমাকে বলতে পারো what does it mean? -47500 joule per kilogram. What does that mean? Yeah, so a kg will require that much joules, right? To do what? Yes, so imagine you have that object at infinite, right? And it's falling. And as it falls and it comes to the point that we have located, to reach this point, how much work needs to be done on it? 47500 joules. Okay, if it was how much mass? 1 kilogram. Do you understand? I'll repeat again. So your mass always starts at infinite. At infinite, what is the energy it possesses? Zero, because the value of G is 0. And as that mass keeps moving into the field, right, it's losing potential energy, gaining kinetic energy, right? So as it reaches a point here, how much energy does it have at that moment, right? At that location is this value, -47500 joule per kilogram. 47500 is the value we worked with, right? Minus means it's losing that energy that's going down. Because as you understand, energy is a what quantity? Scalar. এখানে plus minus কিন্তু represent করে কি? Direction নাকি plus gain or loss? Gain or loss. Okay, so this is not direction here. Energy can't have direction. It's a scalar quantity. So yeah, this is the definition you have to give in the exam. Potential is the amount of work done needed to move a unit mass. Point mass recent papers দেখছি যে ওরা ওরকম emphasis দেয় না, but unit mass from infinity to a point in a gravitational field. So the formula is this, okay, minus gm by d. So when we say that 9.81 joules per kilogram, do we mean that it with 9.81 joules per kilogram to take from the infinity to no, we don't say that. 9.81 is not joules per kilogram, it's Newton per kilogram. And that's gravitational field strength. That's the amount of force it experiences. Which one? Oh, so remember W equals to mg. That g is what? Yeah, what does it signify? No. Yeah, it's the amount of force your object experiences if its mass is 1 kilogram. It's a force thing. And gravitational potential, it's the amount of energy it possesses at that point in the field. Okay, so I'll make it simple for you. So imagine this remote here, right? This remote is here right now. What is the value of G for this remote? 9.81, right? What does it mean? That at this location, if I had a 1 kg mass here, how much energy, how much force will it experience? 9.81. And that is what we call gravitational field strength, right? Now, let's say at this location, right, the phi value, potential value is -7,000. It means when you bring that object from infinite to this point, right, the amount of work done is 7,000 joules for 1 kg mass. Now Now it could be more kg mass, then you have to use ratios and figure out how much more. But for 1 kg, that's the amount of energy or work done to bring it to that point. Now here's the thing though, when you bring the mass to this point, do you need to do work on the system, or does the work do, or the system does work on its own? Like ওই যে উপর থেকে যখন নিচে মাসটা আসতেছে, are you bringing it down or is it coming down by itself? That's why it's negative. If I had to bring it here myself, right, what would the value be? Positive. And you'll find an example of that here. AJ, as you cross this place and go above, right, এই values গুলো সব positive. তার মানে এখানে নিতে হলে ও কি naturally যাবে, or do you need to do work to take them there? Yeah, because you're taking against the attraction, right? তার জন্য এগুলো সব পজিটিভ, আর নিচের দিকে যখন যায় they're all negative. আর এই অ্যানালজিটা or এই সিস্টেমটা তোমরা করে আসছো আগে. I don't know if you can relate to it. There's something called ionization energy. First ionization energy. Do you know what that is? It's the amount of energy needed to remove what from an atom? One electron from an atom, right? Completely from an isolated atom, right? We ম্যাথটা করতে হবে আমাদের. We have a chapter in future called quantum physics, right? Where we see how much energy is needed to take the electron out of an atom. Basically ionization energy, right? ওই ম্যাথটা করার সময় we literally assume that ionization এর সময় the electron goes where? Yes, it goes to infinitely far away. That's the math. So তোমরা যখন ionization energy দেখো কোনো atomer, right? Electron valueটা, that value is basically telling you how much energy you need to provide the electron to take it where? Infinite and beyond. And infinite and beyond যদি নিয়ে যাও, ওই electronটা ফেরত আসবে না, because now the gravitational attraction is gone. It has escaped it. Okay? So যে এই point পর্যন্ত reach করতে পারলে, and if you go beyond this, you have gone beyond the clutch of gravity. Gravity can bring you back again. এখানে কিন্তু মাঝখানে every single location, what will you do eventually? Fall back. এখানে গিয়ে you'll fall back, right? এখানে গিয়ে you'll almost make it but then fall back. If you go here, you won't fall back. Because what's the value of G there? 0. You'll stay. Now if you have a little bit more energy, তখন কি করবা? You can escape. And there's a term for this, it's called escape velocity. Like the speed that you need to escape Earth's gravity. আচ্ছা, we have a math topic আজকে maybe হবে না, next class আমরা করব, that at what speed should an object move so that it can escape the Earth's gravity and fly away. Okay, ওটা math করে বের করা যায়. So weight is not, yeah. So weight and gravitational potential has no connection. Gravitational potential has entirely to do with what? Quantity, energy. Our field and field strength is to do with what? Force. Okay. So yeah, this is gravitational potential. তোমাদের হচ্ছে negative or positive, I mean, একটা note add করে দিচ্ছি, but definition এটা কিন্তু important. Okay. This is the one used in the exam. So exam. And this one is literal version, when it actually কি mean করে ওই জিনিসটাই. আচ্ছা, why does it lose energy when it gets closer? Good question. I think এখানে আমরা দেখছিলাম. So এটা আবার explain করি, why does it lose GP? So সবাই একটু এদিকে দেখো, you have this mass here, and this mass when let go will naturally go which way? Downwards, right? That's fine. And if I want it to go up, I need to do work on it to make it go up, right? So যে work করে উপরে নিতে হবে. As it keeps going up, it's storing what energy in it? Gravitational potential energy. And as it goes here and you hold it here and keep it here, it stores the energy within itself. It's called a potential energy, right? The moment you release it, it will use the stored energy and go back again. The analogy is that of a rubber band. So if you take a rubber band, right, and it's just normal, this imagine the ball is on the ground, and I take the ball up all the way there, and I keep it there. Is there any energy stored right now? Yes, elastic potential energy, because I'm really ছাড়িয়ে এটাকে. If I let go of it, right, will it stay there or will it move down? Move down, right, because you have given it energy. So if I want to take the rubber band against its will, মানে ও তো normally naturally এরকম, right? I want to take it against its will. Do I need to provide it energy or do I need to take energy away? I want to take it against his will, right? Or naturally এরকম. So do I need to give energy or take away energy? Yeah, so যে energy store হচ্ছে. Similarly, in a gravitational field, naturally, where does the remote or the calculator want to be? On the ground, right? And if possible, at the center of the earth. ওই একদম ওইখানে চলে যেতে চায়. But if I want to do something against that, I need to give it energy and take it against that. So I'm doing work here. And there's a definition, a small derivation, AS level, যে কেন ওয়ার্ক ডান করতে হয়। সো এটা আমি জাস্ট দিয়ে রাখি এখানে, ওয়াই ওয়ার্ক, এটা লেখা লাগবে না, জাস্ট দেখো ওয়ার্ক ইজ ডান ইন মুভিং আ মাস ইন আ gravitational field. তোমরা কি জানো এটার অ্যান্সার কি? Why work is done in moving a mass in a gravitational field? Kind of, but এই যে দেখো, you have a mass here and এটার হচ্ছে mass এর value হচ্ছে m, and what you do is, this is the value of your this is weight, W equals to mg. What you do is you take this mass and you take it upwards, right? Can you tell me, if I want to take this mass upwards, how much work do I need to do on it, and how much force do I need to apply? Yeah, mg equal, otherwise it wouldn't move upwards, right? So as you take this mass here and you move it upwards, you take this mass and you move it upwards, right? You're doing work by applying force on the other side. The value of that force happens to be what as well? Mg. And you have risen or changed a height here of del H. What's the formula for work done? The classic formula, work done equals to force into distance, where the force and the distance must be what to each other? Parallel, right? My force is mg and the distance moved is del H. And that's the origin of what you typically call gravitational potential energy. So gravitational potential energy essentially is what? Doing work in moving an object, right? And that means it's gaining energy. Energy can neither be created nor be destroyed, right? So when you work to cortisol, that energy has to go somewhere. Where does the energy go? In the object, right? As stored as potential energy. When you release it, it has to go the way it naturally has to go. Which way? Downwards. So it has to give away the energy that you had given it initially. What is the form in which the energy is given out? Kinetic energy. That's so whenever a ball is dropped, it loses that GP, and the object and the system gains what in the process? K. Okay, so it's basically an exchange of energy. You give it energy, it goes up, it releases, it goes down. So in my scenario that I've provided here, isn't the mass moving downwards? So if it moves downwards, will it gain energy or lose energy? Lose. By the way, এখানে gain lose এর কিন্তু problem কি? It gains a certain energy and loses a certain energy simultaneously. So when a ball is falling, right, which energy does it lose? Potential energy. Which energy does it gain? Kinetic energy. So আমরা কিন্তু এখানে we are referring entirely with which energy all the time? Potential energy. So এখানে কিন্তু potential energy loss হচ্ছে. Of course, there's a gain in K, which has to happen because of law of conservation of energy. It'll be raised until you go to this point. So that's all the work that you did here. So you need to give energy for it to go to that point, and the amount of energy you provide, right, is to take the object to that point. Now, what if you provide more energy than it's needed to get to that point? Yes, and that's how you find escape velocity. Like, you can find out the energy needed to reach infinite, and then if you give a little bit more than that, it'll just go out, it'll never come back. That's how you release it. Okay, so some questions here. আমি question গুলো answer করি because eventually I think that everyone might have these questions in your mind, so একটা একটা করে answer করি. Okay, so first question, why is G zero at infinite? এটা তোমরা পারবা. Why is G zero at infinite? Yeah, because of this equation here. The equation is what? Inverse square law use করতেছে. So the further you go away, the value of G কি হতে থাকে? কমতে থাকে, right? And this equation governs that value. So the variation of G is based on this equation here. And it clearly tells you the further you go, the less the value gets. So that's the first one. Next হচ্ছে, why are there explain the, why are there two potentials of zero? Eta I already mentioned. কেন দুইটা zero? Yeah, so there are two places in any system where the value of your potential is zero. One is at the center of the mass, the other is where? At infinite, right? Why is it zero at the center? Because there's no height. Height is zero. And why is it zero at infinite? Because the field strength is zero. So if there are two zeros out there and you start to do a math, let's say, right, hypothetically, it'll be a problem. Because once you get an answer zero, right, where are you right now? Yeah, it could be any place, right? So to overcome that problem, we decided to consider one of them to be zero. And it turns out which one is the more, I know it's not realistic, but attainable place, the center of mass or infinite. It turns out it's infinite actually. I know it doesn't sound right, but infinite is actually attainable. At least you can attempt to go there. But when you're trying to go to the center of mass, at one point, what will you hit? The surface. Right? So infinitely far into possible. And infinite is a number now. What does infinite actually mean? Very large distances. In physics, infinite there are physics na math. There are ranges of infinite. Small infinite, large infinite. I know it doesn't really sound right. Infinite, it should be a endless number, right? But the one that we are trying to do right now is actually attainable infinite, which means it's a small infinite. I'll explain right now. So if you're an atom, let's say, just imagine yourself to be an atom, right? And your surrounding atoms, right? They're actually so far away that their field strength on you is zero. I will repeat, you're an atom, you have your electric field strength, gravitational field strength. There's another atom nearby, right? Or field strength exists, correct? But you can't experience that field strength anymore. Mathematically, where is that charge? Infinitely far away, right? মানে তোমার কি বুঝছো what I'm trying to say? I will repeat করি. You have mass, so you have a gravitational field strength, right? There's another mass that also has a gravitational field strength. Let's say now you're in space and you are at two edges of the Milky Way, our galaxy. So you're at this edge, another person is at the other edge of the Milky Way galaxy. There's no other mass out there. You're 90 light years apart. Which what it means? Light would take how long to go from this side to that side? 90 years, right? If you actually try to experience the field strength of that mass, it's just not there, measurable, right? Which can only mean one thing. How far is it? Infinitely far away. Now, what I'm trying to say is that distance is so large, right? Mathematically, it doesn't have any implication on you, which is, I don't know, tomorrow math, there's a chapter called limits. Do you have limits in math? No? Huh? You will. I think it's like, when you tend towards something, limits. Okay. So yeah, it's related to that. Which one? It's something that broadens your understanding of the universe, but not practically applicable. I would say 80% of your syllabus is practice. I mean, I don't think you're going into astrophysics. Unless you're going into astrophysics, this chapter is the only thing that's helpful. So, most of your O-level, A-level topics are not that useful. The only thing in entirety of your school that is transferable in future life is math. That's it. Also, not all math, basic math, general math. So, just do general math and start working. That's the best way forward. Because on the A to day, we have the working of an MRI machine. I mean, what are you going to do with the working of an MRI machine? MRI it's not a skill that anyone needs unless you're an A2 student. Gravitational potential is a vector. No, gravitational potential is not a vector. Gravitational potential is a scalar. So it add So if it's a scalar and you have plus and minus, what does it mean? It's basically telling you that there's a excess or deficit of energy, gain or loss, not direction. So you have these bond calculations in chemistry, right? Where the energy value is plus or minus eventually. O levels ছিল না? So yeah, enthalpy. So we plus কি mean করে? Endothermic and minus. So but plus minus actually key direction not excess or less of energy. It's actually excess or less. If it's too much exothermic বের হয়ে যাচ্ছে, positive থাকলে মানে হচ্ছে it doesn't have excess to give out, so it's keeping it for itself, right? এখানে same concept. The plus minus doesn't really mean direction. It's a gaining or losing it. That's it. Okay. Our simple example is you না বুঝে থাকো. Let's say you buy something, right? And you make a loss. লসের আগে কি দেখবা -100 টাকা, রাইট? ওই মাইনাসে কি মিন করে তোমার টাকা লেফটে যাচ্ছে না রাইটে যাচ্ছে? কিছুই না, তো ইটস জাস্ট দ্যাট ইউ হ্যাভ লেস মানি দেন বিফোর, right? You get my point? So just because there's a plus and minus doesn't necessarily mean it's a vector. It could mean that there's more or less of a value. Okay. আচ্ছা, আর কোয়েশ্চেন দেখি তোমাদের কি ছিল। Gravitational, this is a good question. Gravitational potential and MGH is not the same. No, it's not the same. Gravitational potential is for 1 kg mass. MGH is for the actual mass. Okay, so if I want to compare the gravitational, energy of two masses around them, which quantity will I use to compare? Potential. Okay, and if I want to know how much energy my mass actually possesses, what will I use? MGH, or in this case, the potential value. Okay. Okay, so one more equation and then we are done with the topic. মানে এখানে math না করে actually confidence পাবো না। আরেকটা হচ্ছে GP and potential link. খুবই important একটা equation. So look at this. Yes. So if you find MGH with 1 kg mass, that's potential. Okay, look at this. তোমরা ফর্মুলাটা একটু দেখো। I would prefer if you derive it yourself, তাহলে এক্সামে মনে রাখতে easier হবে। Gravitational potential phi is what was the definition? Amount of energy per unit mass, right? So this is gravitational potential energy divided by what? Mass. So therefore, this equation, very handy. Phi is actually GPE divided by what? Mass. Okay. এটা কেন কাজে দিবে? Because আমাদের eventually GPE বের করতে হবে, and this is the conversion. Okay, so copy whatever you want, and then I'll show you a math. Math to দেখলে একটা better idea হবে কি meaning there. GPE by L and GP is MGH. Yes. So phi to হচ্ছে for unit mass. There's no mass in the equation. GH. হ্যাঁ, GH টা, but G এর মধ্যে M থাকে। No, you're right. So you said phi equals to MGH by M. Two masses cancel out. Perfect. So it's GH, right? G key. Gravitational field strength. I would have formula key. So there's a mass there. You need to work on your potential and field strength differentiation. মানে সব mix হয়ে, it's now everything is the same thing for you. Because very close to the surface of Earth, the value of G is constant for a very large distance. So when we did our math, we were a very small part of the Earth's surface, so the value never changed. The math we'll be doing today, right, will go very far away from our mass, where the value of G would change drastically. না এখানে একটা confusion আছে you start to gain right so তোমার height বাড়তেছে but ওইদিকে আবার what's going down g right so at the point it stabilizes and it reaches a maximum so even if you're moving it doesn't change and that maximum reaches at the infinite value so it's like as you reach that point you have a maximum amount of energy you can't gain more than that because height is increasing but what's decreasing at a more rapid rate right g and the decrease in g is actually more than the increase in height you know why because it's a square factor. The way G changes, height changes linearly. So G becomes more dominant. Infinite. Yeah, so the furthest your mass can go till it remains within the gravitational field. So if you go beyond infinite, there's no more field exerted on that mass. So it wouldn't come back anymore. So it's the furthest your mass can go and still experience gravitational field strength. So are you guys done with this? Okay, একটা question করাই তোমাদেরকে can you go to page 9 page 9 এর questionটা করাই আমি এই questionটা করাচ্ছি as an example for you to understand the value that we learn if you have any confusion I think this will help you clarify that আচ্ছা তোমরা এটা একটু ট্রাই করো আমি বুঝাই জিনিসটা কি করতেছি এখানে so there are different points above the earth I've given values of each points here when how far they are screen it too so this is the surface of the earth this is y which is 7,000 kilometers above the surface of the earth and this is x which is 5,000 above y you need to find out the potential gravitational potential at these places so question হচ্ছে find phi at these locations. As you do this, you'll realize what the values actually mean because number ছাড়া বোঝানো একটু difficult হয়ে যাচ্ছে so আমি হচ্ছে নাম্বার গুলো দিয়ে তোমাদেরকে explain করি what they mean so find phi at these locations this formula use করতে হবে formula হচ্ছে phi equals to what minus gm by d there's no square there okay and g value কত gravitational universal gravitational constant 6.67 into 10 to the power minus 11 right so give it a try a value গুলো বের করো তিনটা হ্যাঁ হ্যাঁ এইগুলো এই গ্যাপ গুলো সো এইখান থেকে এখানে পুরোটা এটা। আর এই কোশ্চেনে আরেকটা ক্লারিফিকেশন লাগবে দিয়ে রাখি। What is this distance d? Distance কোথা থেকে? Yeah, always center of mass, okay? Distance from center of mass. Okay, solve করি। So phi z, surface of the earth কেমনে বের করবা? Minus 6.67 into 10 to the power minus 11 into mass of earth হচ্ছে 6.024 into 10 to the power, sorry, 2 into 10 to the power 24 divided by what is the distance? 6400 into 1000. এটা করলে you'll get the value of phi at the surface of the earth. Minus 6.27 into 10 to the power 7 unit joule per kg. Okay, let's repeat this with phi y. Same হবে everything, only distance is different হবে. So 6400 plus 7000. 2.9 into 10 to the power 7. Minus 2.9 into 10 to the power minus. আর phi x টা কত আসে? ডাইরেক্ট ভ্যালু বলে দিতে পারো আমাকে। 1 into 10 to the power 7 joule per kg. আচ্ছা, একটু স্ক্রিনে let me explain something. সবাই একটু এদিকে, don't write anything, 2 minutes. I found the potential at multiple places, right? And you'll find that if you look at the potential value, they are little contradictory. I'll tell you why. You'll find that the value for potential is highest when you're closest, right? And lowest when you're furthest. That's actually contradictory to what it should be. It should be highest when you're furthest and lowest when you're closest, right? মানে জিপির কথা বলতেছি। জিপি highest কি সারফেসে নাকি up in the air? In the air, right? So the further you go away, GP বাড়তে থাকে, the closer you come, GP কমতে থাকে. But if you look at the numbers here, they are opposite. At the surface, the value is the highest, and the further you are, the value is the lowest, right? That is the reason why you have to take what into consideration for your calculation and understanding? The negative sign. And negative sign দিয়ে দিলে, it makes sense, right? Because this is smaller than that one. Do you understand why the negative can't be ignored anymore? Because the negative now gives it meaning. Okay, so yes, this is higher in magnitude, but the negative makes it lower in value, right? Because the negative completely reverses the idea. And that makes sense because when you're at the surface of a planet, the GP should be the least, right? And the further you go away, it keeps increasing. Okay, so yeah, these are the values out there. Eta our next class recap করবো। তোমরা একটু নোটটা আপলোড করবো, দেখে নিও। তোমাদের next class exam, right? Monday. So Monday you have your test on gravitational fields and circular motion, মানে until page satellites, page 7.